So here we go. First thing that we have to understand, when you're putting a fraction in simplest form, what you're doing is you are trying to discover if the numerator and the denominator of the fraction that you have been given can be reduced or made smaller in any way, okay? So in math world, when you hear the word simplest form, you're talking about making the fraction as small as it can go, which pretty much means you've got to get to some prime numbers of your fractions. You will never have a fraction in simplest form if both numbers of the fraction are composite, okay? So that's why we started out this whole lesson, this whole chapter, learning how to discover the difference between a prime number and a composite number. You must know the difference between a prime number and a composite number because you still use those tools to do skills like simplifying fractions, okay? So the first thing that I want you to take note of is if the fraction is proper, so that means, what is a proper fraction? Let's review our brain. Come on, tell me, Connor G, what's a proper fraction? What's it gonna look like?
1 of 6.
Okay, so he said the numerator would be a 1, the denominator would be a 6. So what you're telling me is that a proper fraction has a numerator that's smaller than the denominator. Am I right? Yes. So the notes here tell me that if you have a proper fraction, you're going to use GCF to solve. What's GCF? What's GCF?
Greatest common factor.
Greatest common factor. Okay. So that's what you're going to have to use. So the second little note that I'm giving you tells you that if the fraction is improper, which we kind of played with this yesterday, you're going to use division to solve and your answer will become a mixed number. You did that last night. The only difference that you have to notice is that when you turn it into a mixed number and you get that fraction, sometimes the fraction, which is then a proper fraction, needs to get put into simplest form as well, okay? So let's kind of check out what exactly we mean by this and see if this can make sense to us. Okay, so example number 1. Everybody write down example number 1. So we're looking at a fraction that is a 6 over a 9. So first off, what kind of fraction is this? Colin, what kind of fraction is this thing?
Proper.
It's a proper fraction. So our note above tells us that proper fractions, we use what to simplify? What do we use, Henry?
GCF.
We use the greatest common factor, okay? So we have to figure out if 6 and 9 can be made smaller. So the first clue we have to use is we got to look at the numbers. We have a 6 and we have a 9. Are those numbers prime or are those numbers composite? Yes, Alan. They both are. And we automatically know if they're both composite, what do we have to do?
You have to simplify.
We have to simplify, don't we? We know that this fraction is not finished. It's not in simplest form. It can be made smaller. So now it's time to figure out what's the greatest common factor between 6 and 9, okay? So for some of you, you already see it. But for those of us that don't, you should be using your tools, okay? Every time we learn a lesson, you have this little imaginary backpack that you wear on your back every day that you have math class. You don't see it, you don't feel it, but it's there. And every time I teach you something, that's like a tool that you can use to help you when you come onto stuff that you maybe are struggling with. So in your little backpack of tools, of math tools, you've got all this stuff that you can use to help you. So if I don't remember, if I'm looking at 6 and 9 and I don't know what the greatest common factor is between those, what tool could I use from my backpack to help me to find this answer? Cassidy? I'm going to look for the common factors, okay? So what are the factors? Let's just list the factors, Cassidy, for 6. What are the factors for 6? Okay. Good. Are there any more? Screen's got a mind of its own right now. All right, so those are the factors for 6. But now I gotta see what the factors are for 9, because remember, I have to find the greatest common factor between these two guys, 6 and 9. So what's 9's factors? Who can tell me? Xander, what's 9's factors?
It's 1 times 9 and 3 times 9.
And what?
And 3 times 9. 3 times 3.
What in the world? 3 times 3, there we go. The little eraser keeps popping up. Okay, so now there's our tools. We've used our tools. We've laid our tools out on the table so that we can see it. What's the greatest common factor between 6 and 9? Emily? 3. So what are we going to do with that 3? We found the greatest common factor. So if we're trying to put something in simplest form, what kind of math makes things get really small? Does addition make things get really small? Multiplication, subtraction, or division? Hallie? Division. When we take something and we chop it up into parts, that's what division's doing. It makes things small. So we have to put this thing into its smallest form, its simplest form. So we're going to use that greatest common factor, and we're going to divide each of these by that greatest common factor. What is 6 divided by 3, crowd? 2. Don't say 3. Don't throw addition in there. Careful. What's 9 divided by 3? 3. So you just put the fraction 6 over 9 into its simplest form. Okay? Questions on that? Emily? I can't hear you. Pull your mask down, talk louder. What? What? You didn't have a question? You had a comment? You figured it already? Okay, sorry I couldn't hear you the first time. Okay, let's move down to the second example. All right, so I have another one underneath here. But this time, is this fraction proper or improper? This is improper. So the note above tells us that to turn an improper fraction or to simplify an improper fraction, we have to use division to help. Mace, are you with me? Hey, I feel like some of you guys are just like looking right through me. That you're not really like what my words are not like crawling into your brain and sticking, but they're just kind of floating around in space. All right, so 7 divided by 3. That's our game plan. If you need to show it, write it out as a word problem. Not a word problem, what am I saying? As a division problem. But if you don't need to and you're able to do this, mentally, I love that. That's what I want. But for now, this is kind of a beginning stage of this. So for those of you visual learners, don't be ashamed if you have to show it. Show it to make yourself get the right answer. That's what I want, the right answer. Okay? So walk me through this for a second. Max, I haven't heard from you yet. Max, go. Tell me what to do.
So you have to divide 3 by 6 and 3 by 7, 3 goes in 7 2 times.
Yeah? Okay.
And then you place 3 times 2 is 6, and you place 6 times 7 and minus 1.
Okay, so that 1 becomes what?
Numerator.
And?
3 becomes the denominator.
Beautiful. So my mixed number that I just created from that improper fraction was 2 and 1/3. Now we got lucky because in this mixed number, the fraction 1/3 is already in simplest form. How do I know it? How do I know that? How do I know that 1 and 3 are as low as they can go? Tessa.
Because both of them, they're not composite.
What are both of them?
They're both prime.
Air high five. Nice work. Whenever both of them are prime, like you're done. You can't get any smaller. The other big flashing clue with this is that you're staring at a 1. I kind of have this little phrase. Anytime you get a fraction that has a 1 on the top, 1 and done. You don't got to go anymore. Even if the bottom number was a 6, okay, let's just pretend that the bottom number was a 6. 6 isn't prime, 6 is composite. So does that mean I need to get this thing lower? No, because when you get to 1, you're done. Right. Even if the bottom number was 8,467,293.
Wow.
If the top number is 1, you're done. Okay? All right, so the only way we get better is by practice. So let's jump to our practice page. And I see 4 problems here. I want you to work these. Wait a minute. My numbers are not matching up. I'm like 1, 2, 4, 5. We're missing some. Hang on. There we go. Okay, I see 6 problems. I want you to work these 6 problems and give me the fraction or the mixed number in simplest form. All of them. Now remember, if it's an improper fraction, you must use division, and then your answer will be a mixed number. But make sure that that fraction that you get when you make a mixed number is in simplest form, because if it's not, you're gonna have to simplify it because that made a proper fraction. Proper fractions, you use greatest common factor. No, that's improper. Remember, when it's improper, you have to use addition. Yes. So like number 1, when you come up with an answer for number 1, it should be what kind of a fraction? It should be a mixed number. 1 should end up being a mixed number. Yeah, because it's starting as an improper fraction. And improper fractions always turn into mixed numbers. Number 2, what kind of an answer should that one be? That should also be a mixed number. What about number 3? Mixed number. Number 4, should it be a mixed number? No. What about number 5? That should be a mixed number. What about number 6? No. Question? So which one are we on? Number 1? Yes. And then that's your final answer. Yeah, you don't have a fraction left over. Yeah. Because you didn't have anything. This one. Good. And that's, I want you to put it into its final answer. Let me see. This one looks good. So this one goes, is it a 7? Yes, that one's good. That one's good. Now, this fraction right here though, buddy, this is what we're learning. 4 and 10 is not in simplest form because 4 is composite and 10 is composite. So now you have to take that fraction and reduce it even more. So that's where you gotta find the greatest common factor. There's a greatest common factor between 4 and 10. What's the number that they both share? They do. So now you have to divide each of those by that 2 to make that fraction as low as it can go. Good. Now, and pull this 2 over with that new fraction because then that's your final total answer. See what I'm saying? Don't erase your work. I like seeing your work. Work's important to me. It lets me see what your brain is thinking. And then that's the final answer. But yes, you're doing it correctly. Yes. That's fine. That's fine. So Rory was saying that for number 1, as well as for number, well, you need to relook at number 6. But for number 1, You won't have a mixed number for that one, even though it is an improper fraction. Why is that? Why is that? Brady?
Because the number can go into it, void.
Perfectly, right. There's not anything left over when you work that problem out. So are you gonna have, remember the fraction is the leftover stuff, and if you don't have anything left over, then it won't be mixed number.
I had the right answer, but then you told me it was mixed fractions,
Oh,
so
you
I changed
Second
it.
guess yourself?
Yeah.
All right, so let's kind of check these out. I'm gonna pull people up to the board. Unfortunately, the people at home are not gonna see this because we're gonna spread people out on the actual board. But I would like for, let me get my phone and we'll just do random name case. Let's go with, first one chosen is Dominic. Come on up to the board. Dominic, work problem number 1 on the board for us. Number 2, Allie, you get to come to the board and work problem number 2. If I choose you and you haven't completed that question yet, it's not a big deal. You just completed the board. Number 3, Sophia, you're up for number 3. Number 4, Shane, you're up for number 4. Addison, you're up for number 5. Emily, you're up for number 6. Okay. You were 3.
I was number 5, right? Yeah.
We gotta find spaces. Look, you can move the chair down there. Somebody move the chair, or look, Emily, come over here. I'll move this thing. Y'all gotta give Emily a space here somewhere. She's gotta squeeze in somewhere. Okay. All right, so these people are gonna work these problems. They're gonna show you how they got the answer, and hopefully they have put every fraction into its simplest form. Put your the number of the problem you worked next to your problem, if you don't mind, please, so that Dominic, you already did. So that the audience can kind of see. So number 1, now the only thing I will say, I don't want you to put that fraction there. Go get rid of that fraction that's next to your whole number. Dominic, you don't need to have 0 over 3. You don't need that. That basically means 0, so we don't need to put anything since there's nothing left
So
over.
there's a 0 on top, you don't need to put it.
No, you just leave it as the whole number. So number 1, the answer should be 4. Number 2, Allie worked number 2. She got 1 2/5. 2 and 5 is in simplest form already because they're both prime numbers. So Allie knew she could leave it that way. 1 2/5 is the final answer. These people, number 3, who had number 3?
Sophia.
All right, Sophia's still working on number 3. Where's number 4? Down here with Shane? All right, so Shane had 24 over 30. His was not an improper fraction. His was a proper fraction. So he knew he had to find the greatest common factor to simplify. Shane, the greatest common factor you found was 6. So when he divided his numerator and his denominator by that 6, he got 4 over 5. That's the correct answer for number 4. Okay? All right. Number 5. Come on, girl. You need to move it a little quicker. Number 5. 16 over 7. This is an improper fraction. When she does her math, she comes up with 2 and 2 sevens. 2 and 7 are both in simplest form already. Why, Addison?
Because 2 and 7 are already prime numbers and you can't get any lower.
Beautiful. So 2 and 2 sevens is the final answer. Emily came up with 15 over 30 was hers. Was yours an improper fraction or a proper fraction? It's a proper because the small number's at the top. So she had to use GCF to solve. Now here's my thing though, Em. All right, so Emily found a factor that they had in common. But I'm gonna ask the audience, is the greatest number that 15 and 30 have in common 5?
No.
So, but do they have 5 in common?
Yeah.
Yes, so she chose 5. And she came up with 3 over 6. She's on the right track. She just didn't make it to the finish line yet, did she? Because they still have another number in common. 3 and 6 still have another number in common. What do you see that 3 and 6 can still be divided by? Yeah, so now divide that by a 3. The rest of you hold on for a second, because go ahead, let her finish her problem, okay? No. You just said they both share a 3, so you're gonna divide each of those by a 3. And when you do, what do you get? Good. Perfect. So for number 6, the final answer should have been 1/2. Now, Emily, hang here with me for a minute. Crowd, what's the greatest common factor between 15 and 30? 15. Okay. You started with a 5. Okay. Which was not the greatest common factor, but it was a common factor. So that's why I said it's not that you're wrong. You were doing things right. You just got to a spot where you weren't finished. So then you had to divide some more. What was the next number you had to use to divide? 3. And once you use that one, then it got you to your final answer. But look, what's 5 times 3? 15. What's the greatest common factor? If you would have started, babe, with 15, because that is the greatest common factor, and if you would have divided each by that 15, what's 15 divided by 15? What's 30 divided by 15? And you would have had the final answer right from the start. So do you see how you just had to do a little more work? But I love that you did that because it helped us all to learn, okay? I don't want you to think that you can't get the right answer just because you didn't pick the greatest common factor. You can, you just have to do more work. It's kind of like jumping through more hoops to get to where you need to be, okay? And then, which one, number 3, that was the only one we had left. This one was improper, okay? So she came up with 2 and 4 10s, but 4 and 10 she knew was not in simplest form because 4 is composite and so is 10. So now she knew I have to reduce this thing even more. What number does 4 and 10, what's the greatest common factor, Sophia, between 4 and 10? 2. So she had to divide each of these by a 2, and she came up with 2 and 2/5. So how many of you were 6 for 6? Who was 5 for 6? 4 for 6? 3 for 6? All right. So if you missed any more than 3 of these, then you need to come to me at some point today and let me try to help you a little more, because these things are just kind of carrying on with what we did last night, but it's necessary that you know how to do this because this is what our next chapter is all about, okay? All right, your assignment this evening, unfortunately we didn't get class time to start, but I will tell you that when you have your religion test today, you can use times like that to kind of work on it if you get opportunities. Your homework this evening is going to be to complete workbook pages 87 and 88, but I'll only make you do the evens. So how about that? Okay. 87 and 88 evens only. Okay. Yes.
That's cool.